All right, so good morning, everyone. Let's go ahead and jump right in. I know this is kind of a weird circumstance, and I'm glad that you're watching this video. And I'll make sure that my slides are posted as well, as just in case you want to see um, the stuff that I'm following along, or hopefully that you're following along with me. So today we're gonna jump ahead a little bit from what I normally like to talk about and teach about, mostly because I know that this is a smaller topic that is, I don't know, easier when it's fresher, when arrays are fresher in your mind, which you all just did your test on it, so it is hopefully fresh in your mind at least a little bit. So we're going to talk a little bit about collections and more specifically lists and array lists today. And I'm sure I'll put some instructions when I finally post this video, which hopefully should be in an hour or two once this video encodes a little bit better. Um, I'm going to post some instructions for going to the AP Classroom and answering some questions on there to sort of test sort of some of the stuff that we've been talking about and that we're going to be talking about today. So let's jump right in so that we don't spend a whole lot of time on this. So when we're talking about putting data together and creating data structures, which is a big portion of computer science in general, is posting data and putting data together. Um, we've sort of been storing data in three different ways. So we've had primitive data, so that's ints, doubles, characters, uh, long, short, all these different data types, mostly numbers, a couple of different characters and things like that. We have objects, so things like the dinosaurs that you all created, the cars you all created, and arrays that we talked about. So arrays, 2D arrays, 1D arrays, which is all storing different information all in one place. Now, these are nice, but I can tell you right now that these are a little rigid, at least specifically arrays. They're a little rigid. So we talked about before how we can create an array with a certain number of things, but we can never expand it. We can never go over it, um, which is kind of a problem. Because, for example, if I start out school and I say Northwood is going to have 1,700 students, what happens if a student moves into the area and I don't have a place for me to put them into my database? So that's a big problem to have, and sort of anticipating um, that we might run into more data later on is something that's important. Now you could say, let me just make an array of size 2,000, but you never know having 2,000 things rather than 1,701 necessary. That might be an extra cost or um, unnecessary for you to go through. So today we're going to talk about how to solve that problem, and one of the nicer ways of solving that problem in Java. So when we talk about collections, and collections, I'll explain what they are in a second. They're essentially, you can think of them as a Pokedex. So it's just one general place that we can put all different kinds of stuff inside. So we have lots of different Pokemons, lots of different types. Gene, I don't know. I'm not a big Pokemon fan, but you can sort of see that there's a wide range, even if you've never played Pokemon before. So this is essentially what collections are. Um, they're going to be in different categories, much like Pokemon. Um, and in those categories, we're going to sort of be using maybe one or two of different collections, different ways of storing data. And that's going to be lists specifically in this class. And if you stick around with computer science, you'll see more other types like array lists, maps, and sets, and things like that. We won't talk about those a whole lot in this class just yet. So collections is the general term of having a place to store lots of information, and there's lots of different sub sort of types in there that allow you to put different things in different ways. So collections are essentially a superclass, and we'll talk about superclasses more in the next unit, but essentially think of it as a mother class, the class that everything sort of is under. So for example, for us, humans are the general thing that we all fall under. And so collections are the general super mother of every single other data structure, um, at least in Java. And in there, we have lots of different types. So, for example, we have strings are technically collections. They're a collection of characters. We have lists. which we're going to talk about today more specifically, stacks, queues, sets, maps, trees, graphs, all these different ones are things that have been implemented in Java that have been written, and they're just different ways of storing information. For example, here, a stack is sort of like having a stack of paper. It sort of processes information in this LIFO order, which is just essentially means last in, first out. Which means if you hand me a whole bunch of pieces of paper, as in when you all turn in your tests, the last one that is on the top of the stack is the one that I'm going to grade first because it's the first one that I'm going to see. And so that's just a different way of storing information. So for example, if you want to sort through information in that way, you want to process information in that way, this is probably a better way of storing it. Queue is another way. Queue is essentially a line, like if you're getting in line for the bus. So as you're getting in line, the first person who got in line hopefully is the first one to get on the bus if the line doesn't fall apart. And so that again might be another way that you want to do things. So for example, like the help desk tickets that we do in class sometimes, to help out students. Um, the first person that puts their name on there is the first person that I'm going to go to, and then the next person after that, and then the next person after that, and then so on and so forth. And so it's just different ways of storing. I'm not going to go through the rest of them because they're not super important, but we know at least these first two, strings, and we're going to get to know lists today. Those are the two ones that are going to be important for the AP and for now, your life in Java. So let's move on. All right. So why do we care about having all these different types? It really comes down to what you want to do. And so the big things that we will want to do and that we're going to talk about in this sort of subunit is how to search and retrieve elements, remove elements, insert elements, replace elements, traverse through data, and determine the size. Some of these have been easier than others with arrays. For example, here, traversing the data, we can just write a loop. Determining the size, we just call dot length. Um, Removing elements, that's kind of a hard one because we can't really remove a cubby hole from an array. It's already a set size. Searching and retrieving, we've done a little bit of that with our choose your own adventure. But this really dictates which one you want to use because all of these different types have different ways of doing that and processing data. And so it really depends on you when you become a developer to see what is my problem, how do I want to solve it, which one of these is better for solving that problem. And that's essentially what computer science is in general anyway. We're just giving you tools and you have to sort of figure out, using the tools that we know, how are we going to solve that problem. So um, where do we get our list from? So java.util is something that you've probably seen before when we're importing things. We do like import java.util.scanner at the very top. So that is essentially a package that you haven't written, that somebody at Oracle has written, that has lots of different implementation of different classes in there, and we're just importing it so that we can use all those different things. So for example, we get all of these different interfaces. You don't quite know what an interface is just yet. We'll talk about that in the next unit. But essentially um, think of it almost as a family tree where we have iterable is the very top one, collection is the next child, and then queue, list, set, map, and all these different things are under it. Essentially what this means, and all I expect you to sort of know, is um, iterable just means that we can iterate through it, which just means that we can write a loop to go through it. A collection, again, is what we're talking about today, so all of the different data structures, like all these that we talked about before, fall under collections. Lists, again, are really going to be the ones that we specifically look at, but there's other different types that are implemented. And then from there, we have, so collection is here, like we just sort of talked about. In there, we have list that has all of these different types of lists in there, and then a queue, which is a different type of different sort of implementation of collections. Again, we're sort of just going to talk about array lists, but just know that some of these exist. Stacks exist. Vectors you'll never really see ever. I've never dealt with a vector before. But linked lists are another way of implementing the list interface and so on and so forth. So again, just think of it as a family tree where iterable is the very top, collection is the next one, list is the next one after that, and in list we have implementation of different classes, so different ways of storing information. So a linked list sort of does the same thing and has the same methods as an array list, but it does it in a completely different way. For example, stack here has similar methods, similar implementation, but it does stuff just slightly different than an array list. And again, it depends on how you want to solve that problem, what you want to do, that dictates which one you want to use. And in this case, we're just going to be using ArrayList. I'm going to skip over this for now. All right, so lists. All I'm going to say sort of about this slide here is normally I talk about this after we have talked about interfaces, but all I'm going to sort of say is lists aren't a class. Lists are essentially just a type, and we'll talk about that in a moment because it'll get too confusing if I sort of just dive right into it. So here's an example here. So here we have lists and then the name of the list. So it's the same way that when we create variables, we do like string, name, equals, and then something on the right side. This is essentially going to be the way that we create lists. List, the name of the list, equals, new, and then whatever the class that implements the list. In our case, it's going to be ArrayLists. So I'll show you a sort of good example in a moment. So here's one right here. So list test list equals new ArrayList. And now this is going to be essentially what we're going to be doing. So a list is just a general type, equals a new array list, which is the actual class that uses the list interface. You'll see this sometimes with the AP exam, the way that they write it. We're just generally going to be doing array list on this side and array list on that side as well. But this is sort of to expose you to what the AP might be doing. So just in case when you look at the AP Central or AP Classroom examples that I've posted, you might see this in there. So this is close, but not exactly how we're going to do it. And this leads into a different topic, but let me just go right into Eclipse over here and show you exactly what we want to do. So, new class, come on. Oops, not what I wanted. New class. All right. So I'm going to create a class, and I'm just going to call it ArrayList practice. All right. So ArrayList practice, and I created my main method in there. Right now, sort of like what I showed you, we're going to be doing list name equals new array list. That's one way to do it. The second way to do it is if I do, I'm just going to copy this and paste it, and this is the way that I'm typically going to recommend you do it in this class, is you just do array list name equals new array list. So array list on this side and then array list on the second side. Let me import this real quick. So make sure that you're importing from java.util. It's this third one. Sometimes it pops up as the first one. Sometimes it pops up as the last one here. So just click this. It'll import it. And you might have to import again. Import array list. There you go. Okay. So notice here, we don't have any errors, but it also isn't terribly happy with the way that I wrote it. So let's see what the issue is here. List is a raw type. References to the generic type list should be parameterized. So this is what we're going to talk about next. This is a way to do it, but it's not the perfect way in the way that I want you to. It's like 95% the way there. So let's talk about what we need to do to fix it. So essentially, lists and array lists can only store objects. So that means that if I wanted to store an object, for example, I have I think this is a sample. No, that's not it. Let's say that I create a person object. person. Okay, so let's assume that I have code in here to create a person object. So I'm going to go back to my ArrayList, and I'm going to say here, and I'm going to delete this first one because I don't want to necessarily write it that way. So I'm going to do ArrayList on this side, ArrayList on that side. What you need to do is in between here, you write the type that you want to create that ArrayList for. So for example here, if I want to store a whole bunch of people, I'm going to do person on this side and person on this side. Make sure that you do it between these two carets here. This is sort of the same way as me in an array doing int bracket and saying nums equals new int just like that. So by me saying int over here, I'm saying that this array is going to be of type int, so it's only going to store numbers. That's the same thing that I'm doing here. I'm saying I'm creating an array list here, and let me make this a little bigger. I'm creating an array list here, and I'm saying I'm only going to store person objects inside of it. Person over here as well. And assume that a person has already been written, I can store people in there. And so that's the way that I create an array list. Now the issue is, what if I don't want to store a person? What if I want to store numbers? Because our examples before, like int and double and character and boolean, all of these are not objects. They are primitive data type, as we sort of talked about before. If they're lowercase, they're a primitive data type. And I can't, even if I want to, I can't say int in here and int in here. It doesn't let me. It doesn't like that. Again, because going back to my slides here, I can only store objects. I cannot store primitive data types. And so our way of getting around this are what we call wrapper classes. So wrapper with a W. Essentially what a wrapper class is it takes a number itself, just like a primitive data type number. It stores it inside of an object called whatever that type is with a capital N spelled out completely. And it's going to now package it up into an object that has that number inside of it. So for example, rather than me saying int num equals 34, it does this down here. It's going to say integer, capital I, integer spelled out, num equals new integer with the number 34 in it. And so this is essentially what we call boxing, automatic boxing. So when we add a number into the array list, it's going to automatically take that number, it's going to auto box it, and it's going to create an object with that number inside of it. You won't really be able to see that it's doing that, but I want you to know that that's sort of what's happening in the background. And so the way that we designate for it to do that is instead of using int, we write out in here integer. And over here, integer. And now it's going to say, I'm going to store integers inside of name2. Or let's do this let's call it num. Inside of nums, it's only going to store integers. So now we've essentially created something similar to an array that we did before, similar to int bracket nums2 equals new int bracket size 9. Similar thing here. So rather than using int, we use capital I integer on both sides there. Now, let's see what I have next before I sort of jump right into. Okay, so a couple other things that I sort of want to say. Don't forget here, and this is something that happens a lot. This sort of looks similar to this over here. Oops. But make sure that at the very end here you have the parentheses. So these parentheses are important because if I don't have them, it's not going to allow me to create it. This is essentially calling the constructor for ArrayList to make sure to construct an ArrayList. So let's talk about the differences here, and I'm going to sort of create them as comments down here. With an ArrayList, we have no size that is defined ahead of time. No size defined ahead. So for example, here I have a size of 9 in this array, but in this one I have no size defined, so right now there's nothing inside of it. Absolutely nothing. And so I have to actually add things in, and it'll add them in whatever order that I add them in. And we'll talk about what that looks like in a moment. In here, I can also delete items. And I can delete them pretty easily. And so if I delete things, for example, if I have the numbers 1, 2, 3, and 4 inside of this array list here, inside of nums, if I delete the number 3, which I'll show you how in a moment, everything shifts over. Everything shifts to the left. So now 1, 2, and 4 are in there. My size is now 3, and my indexes are 0, 1, and 2. While before, if I had the 3, before I deleted it, I had indexes of 0, 1, 2, 3, with the numbers 1, 2, 3, 4 inside. And so it was a size of 4 with the indexes 0, 1, 2, 3. And that leads me sort of towards the last thing. Our indexing works the same. So I can access things similarly. At least the numbers are very similar compared to an array. So the same way that this has a size 9 in it, or should have 9 things in there. So 9 zeros in this case. This one has nothing inside of it, but I can add 9 things in there, and the indexing will work the same way. So I can access them. 0 is the first thing, 1 is the second thing, 2 is the third thing, and so on and so forth. So it works the same way. So let's look at some of those ways to actually change the array list and modify it. So here is a nice compiled list of the things that are going to come most in handy for you. And so I'm just going to go down the line. I'm going to quickly explain each of them. Is empty will tell you whether or not the array list is empty. So it'll give you a Boolean value. And in this case, let me just stop here. Let me say, I'm just going to system.out.print each of these things. So sysout, control space. I'm just going to say nums.is empty. So I haven't added anything into this array list called nums. So when I run this, it's going to give me true because there's nothing inside of it yet. So it's pretty self-explanatory. Next we have size here. So size is going to work the same way as length works in our arrays. So in this case, I'm going to do .size. And again, because I have not added anything in here, you can sort of assume what it's going to be. It's going to be 0 because it's empty. Nothing inside of it. I'm going to skip around a little bit just because I haven't added anything in there. I'm going to skip from size all the way down to here where it says add. So add is the way that we're going to be actually adding elements inside of there. Now, I'm going to go show you an example. So in here, I'm going to add nums.add, and I'm going to add the number 67. Notice here, even though I said integer over here, and it only takes in an object, I still only passed in a primitive data type, just a number. I didn't have to create an object. This is because of what we talked about before, the auto boxing. This is essentially the same thing as me doing this. Integer num equals new integer 67. And then me taking that, why didn't you like that? Oh, it doesn't like that. I'm doing that. That's fine with me. This is kind of the old school. I'm just showing you how it sort of works in the background. So integer num equals new integer with the number 67, and then it does nums dot add. Come on. Uh-oh. My Eclipse is frozen. Okay, there we go. Dot add num in there. This is essentially what it's doing. So this line right here is saving you from having to create a new integer and then adding that actual object inside of there. So adding the wrapper object inside of there. So this is what we call wrapping. So it's wrapping the primitive data type um, into an object that then nums, which is an array list, can consume easily because it can only consume and store objects. So this is what's happening in the background when you do this. It's auto boxing. So it'll take the 67, create an object of integer in it, and then pass it in and store that inside of there. And so you don't really have to do this, and you can see that it says that it's deprecated, which means that it's not supported anymore. This is the way that I used to have to do this when I first started to learn Java, just because auto boxing wasn't something that they wanted us to do and rely on. And so, yeah. All right, so this is adding 67. Let me add a couple numbers. Nums dot add 90 and nums dot add 45. So now you can sort of hopefully see and sort of assume what the size is going to be here. I'm just going to run it so you can confirm. Should have 3 things inside of there. I added 3 numbers in there. And then I can go back to is empty again. And now it's going to tell me false because I've added elements in there. There's 3 elements in there. All right, so let's go back to our list. Make sure we're not missing anything. Okay. Now we can use the .get method over here since we've already added some things in there. So if I want to access the first element in the list, I can do nums.get, and then in here I pass my index that I want to get. Now, the important thing to note here is what is the order that it's going to add all 3 of these things. Now, it could add it the 67 at the front, the 90 next, the 45 next, or it could do 67 at the front, and then it adds the 90 before it, and then the 45 before it. So our 2 options here could be this. 67 first, then 90, then 45, or it could do 67 first, then scoot over the 67 and put the 90, and then scoot over the 45, or sorry, the 90, and then put the 45 in there. Are 2 options. So sort of take a guess which one you think is going to go. And the way that we can confirm this is if I do nums.get 0, as in get the first element, it should give me either 67 or 45. So let's go ahead and run it. And it gives me 67, which means that it adds it in sort of the first way that I described there, which means it adds the first element, and then every single one that comes after it will just be added to the end. So 67, then 90, then 45. And we can confirm that by doing nums.get 0, nums.get 1. Yep, it's 90. And then nums.get 2, which is 45. Let's try nums.get 3. Oh. Let me try and expand this a little bit. Notice we got an index out of bounds exception. Make sure you know why that just happened there. Hint, hint, we've only added 3 things. So what are our indexes for those 3 things? So that's how we get elements. Now, before I move anything, actually, let me do one last one. Let's do remove. So remove is going to be, you'll notice here that there's 2 of them. There's remove here and remove here. The same way that there's an add here and an add here. Um, so this is what we call method overloading, which means having more than one at one time. Um, but essentially what these two different ones are saying is this first remove method is going to remove anything at whatever index you pass in. Or you can call remove that will remove an element itself. And I'll show you the difference here. So, for example, I could remove the element at 1, which right now will give me 90 here, because 90 is the first element, because these indexes, again, are 0, whoops, 0, 1, 2. Yep, so 90. So in this case, it's going to remove the 90 and then also return it to me. So you'll see that it'll give me the number 90. Yep, gave me the number 90. And if I now down here say system.out.print the size of it, nums.size, it'll give me 2. Sorry, 2. Because I removed one thing. There was originally 3. I removed one thing, and it gave me 2 because I took it out. Now, notice here, if I remove this element, the 90 right here, it'll shift everything over, like I said before. So it'll shift this 45 over. So this means that if I do nums.get at element 1, this will actually give me 45 because the 45 is shifted over. So anytime you remove something, all of the elements to the right of it will shift to the left. Now, since we don't want any empty spaces in there, it'll accommodate and shift everything to the left. It's important to know. All right, so the second way we can remove is this one right here, Boolean remove object element. What this does is, instead of removing and passing in a number here, passing in a number there, I'm going to instead pass in an integer object. So in this case, I'm going to do remove, let me do it this way. Integer num equals new, integer, and I'm going to remove the number 90. So again, it's going to tell me it doesn't like it, but that's fine with me. Integer num equals new integer, and then I'm going to remove num. So what this is going to do is it's going to search through this array list, and it'll find the first integer that has the number 90 inside of it and remove that one using this. So if I go back, it's going to return to me true. That means it found a number with the number 90, an integer with the number 90, and it's going to now tell me that the thing at position 1 is 45. And again, that's 45 because the 90 was removed, and so it shifted over to the left. Now let's give it something that is not there. Let me give it 91. There's not a 91 in this array list, so it's going to search through it. It's going to say false because it didn't find one, and then it's going to return me the 90 because the 90 was now removed. And now there's still 3 elements inside of it. So that's the other way to remove. Just to go back a little bit, I forgot to talk about add. There's also this other add element over here. I could do this, nums dot add, and I'm going to say at position 0, I'm going to add the element 45. Actually, let's do 89. So what this does is you can tell it a target place you want to add it into and what the number is. And so now it'll add 0 at the 0th place, the number 89, shift the 67 over, and then now we have 4 things with an index of 0, 1, 2, 3. So Again, there's two ways to add. You can just add a number and it'll add it to the end, or you can add it to a very specific place. Now, be careful to not add something a lot later on. For example, I could add something at element 100, so it'll do 89, 60, or sorry, it'll do 67, 90, 45. And then because I'm adding it at element 100, it will actually create some space in between here until we get to the 100th element, add 89 there, and it'll be index 100 is where that 89 will be. The problem here is everything in between here is going to be null, and you don't want that. You don't want just empty space there. So just be careful. Only add things to where you know there's already values surrounding it, or to the very end, at which point you might as well just use nums.add and just add the number to the end using this way here. So those are two ways to add. Actually, delete this. There we go. All right. Let's see if there's anything else I want to talk about. Talked about remove. Last one here, set. I'm not going to go over this one just yet, but essentially what set does is similar to add over here. You can tell it an index you want to go to, and it'll change the value there to whatever the value is that you change. I might as well go over an example. So, for example here, if I do nums.set at value 2, I'm going to set it to 78. For example here. So now I'm changing the index 2, which is going to be the 45, to be 78. And so it's actually going to go in there, change this 45 to 78. And now we can sort of confirm that by printing it out, and it'll be 78. So pretty self-explanatory. All right, last one, index of, same thing. You can pass in, it's sort of like the index of for string. So you can pass in an element and it'll tell you where in the array list it finds that element. All right, so last order of business that we'll talk about, and that's writing a loop to go through an array list. If you want to try it yourself, you sort of already have the tools for it. You might as well try it. But if you want the example, if you want to try it yourself, just pause the video and then we'll go over the example in a moment. But if you want sort of the hint for it, just keep watching. All right, so we're going to go through with a normal for loop. I'm going to say int I equals 0, again, because our indexing starts at 0. And I is the number itself that is going to each index. Int I equals 0. I is less than, and here's the finicky part. You will want to do nums.length, but length does not exist. It's going to be size. So nums.size. I++. And now I'm just going to sys out nums.get I. Again, .get is the same thing as me in an array doing R I. It's the same thing, except for array list, we have to do it this way. You can't use the brackets. So we're going to go ahead and run it. Let me comment this out right here. Comment this out right here. It should give me 67, 90, 45 in different lines. Let's see if it does that. Yep, 67, 90, 45. So now we can sort of see everything that we could do with arrays, we could do with variables, we can now do with array lists. And again, I'm just going to cover this again. If you need to do this for a different type other than integer, you need to do it for a different primitive data type. For example, with double, it's just going to be capital D double instead of lowercase double. If you want to do a character array, all you have to do is use character spelled out with a capital C. If you want to do Boolean, you can just do Boolean with a capital B. and so on and so forth. So all of these on the right side are what should be replacing integer here if you want to make it um, of some other number type. Um, String will just immediately drop in here just because it is already an object. It's already uppercase and spelled out, so there's no need to change anything there. And if I wanted to add strings here, I just put everything in quotes as I normally do. Um, and we're good to go. Print this out. Yep, works the same way. So just to recap, again, we can do anything we can do with arrays with an array list. Make sure you create an array list just like this. Array list, and then the object type, which is going to be one of these or integer. Just going to write it down here. Int is integer. You're going to replace one of these in there. Make sure it goes on both sides. Make sure it goes between these greater than and less than symbols. And then make sure that your parentheses are here, or else it's not going to work. We add things using .add. We can remove things. The size can change as much as you want it to. You can use .size to get the size. This is how you print. And all of the other methods that we might need to use are right here. So familiarize yourself with these. The only one you might not need to do, and it's the one that's been covered by the slide ticker at the bottom, is iterator down there. Don't worry about iterator just yet. We'll talk about that a little bit later on. So I think that's all I had for you all. So go ahead and test this out. I'm not going to create an exercise for it, but we will have an exercise as soon as we get back or as soon as this break is done. I might post something next week just in case you want to start it out before school starts and you have some time. You might as well do it. This is usually, I think it's about 10% of the exam. So, and there's always a free response question with it. So make sure you familiarize yourself with it. Do the AP questions that I've posted. Try your best with them and test them out. And let me know if you have any questions. Please email me as soon as you have questions, and I'd be more than happy to help you. I have my email open at all times. So, yeah, thanks for bearing with me. Hopefully the sound is okay and not too soft or too loud. And I will talk to you all soon.